Hello friends, welcome to C# Intermediate to Advanced tutorial. Now you are watching part 2. Now you are watching a second sub-series. In this sub-series, we will learn how to use ThreadPool and how to allocate thread in a ThreadPool to service a task. So in this video, we will learn the basics of C# ThreadPool as well as task. ThreadPool is a collection of pre-created threads which service a specific task. So you see, ThreadPool, collection of thread, and a thread will perform a task. For example, a web server which receives a request and sends a response can be serviced by a ThreadPool. So here you can see receiving a request as well as sending a response together can be seen as a task, and that task can be serviced by a ThreadPool. ThreadPool means the ThreadPool will take care of assigning this task to a thread which it is managing. A ThreadPool will have maximum of say n threads. So here we are not specifying a number. It can be a 20 or 25, and it depends on the OS nature, or it's a varying one. So today it is fixed to some number, and tomorrow it will change. So we can say a ThreadPool will have a maximum of, say for example, 25 threads, and this 25 thread may change based on hardware improvement in future. The thread in the ThreadPool will be assigned with a task. So as already told, a ThreadPool is a collection of thread, and a thread in a ThreadPool will be assigned with a specific task. That means the task will be executed in a thread. When a thread finishes the task, so when a thread means here, when a thread in the ThreadPool finishes the task, it is free but not destroyed. That means in a ThreadPool we will be having a collection of thread, and a thread is assigned a task, and let's say the thread finishes the task. So ThreadPool won't destroy that thread. The thread will be free, but a ThreadPool will not destroy it. That means the ThreadPool will have that thread ready to service any next incoming task. The ThreadPool will check the queue of task. So there are two queue here we are talking about. One is queue of thread managed by the ThreadPool, then queue of task that needs to be executed on a thread. So the ThreadPool will check the queue of task and assigns the free thread to service it. So once the thread takes care of executing a task, it will execute it, and once the task finished, it will become free, and when it becomes free, it will still stay on the ThreadPool as a free thread. So likewise, there can be multiple threads that will be servicing the task, and once they finishes the task, they will return to the ThreadPool and waiting for next task in the queue. Let's say we have a ThreadPool, and the ThreadPool is having 5 threads. So these threads are free and made ready and waiting for the task to be assigned. So let's say we have a task queue also. So it will be added by the external world and picked by the thread pool. So whenever a new task enters, it will, or in our example, if we take a web request, a new web request comes and it stays on the task queue. So likewise, if you see here in this picture, we have 4 task queue, and let's say these threads are engaged already and only 2 thread is free. Let's assume like this. So the thread pool will look for a free thread. Say for example, this thread is free, and it looks for the task queue also. Let's say this is the first one in the queue. So it picks the task and it picks the thread as well and assigns the task to the thread queue. So if you see, the task here in our example is receiving the request, processing the request and responding back to the web application, we can say. So here thread pool, it takes the free thread. So these are all already working or servicing the request response system. So this is the free thread. It retrieves that and takes the free task from the queue and executes this task in the thread. So this looks like a parallel task now, right? Similarly, if there is one more thread in the queue, it assigns the next thread and executes the task in the thread. So now all threads are busy. There are still two tasks waiting in the queue, and there will be a possibility that one more new task will come and wait on the queue. So once this thread finishes the task, it will be returned and stays in the thread pool. So it will not get deleted. Similarly, when this thread finishes, it will be returned and waits in the thread. Similarly, when this thread also finished, it will return to the thread pool. So totally, if you see, now thread pool contains 3 threads and these tasks are finished and there are 3 in the task queue. So now it will be, the free thread will be allocated to this task. So likewise, the thread pool will work. So all these tasks at a time, if you see, work in parallel. So this task will execute and this task will also execute. So T1 in thread pool and T2 in thread pool runs in a separate thread. That means there are 2 tasks that is serviced by 2 threads. So this is how thread pool work. And now you got the idea of what is a thread pool: collection of thread, collection of task. Thread pool will assign a thread to the task. Once thread finishes the task, it returns to the queue. That way, a fixed number of threads will service the task queue. When all threads in the thread pool are busy, then the task in the task queue will wait for the free availability of thread so that the task can be serviced. Here, the overhead of thread lifecycle, because here if you see, these are all pre-created thread. They service the task, and once the task execution finishes, the thread will return to the pool. So in this sequence, if you see, the overhead of thread life cycle, like creating a thread, starting it and destroying it, all are avoided. That means, so they will be created and kept in a thread pool, and they will be there for a long period of time, and they will be servicing the task queue. So the overhead here means each time you no need to create a thread, start it and destroy it. So this will save time when you are using the thread pool. So the overhead of thread lifecycle can be avoided when using the ThreadPool. So that's all here in this video. Thank you for watching. Bye.